Adam. Thanks for taking the time for this interview. First of all, I would like to ask you who you are and what is your company doing.
So my name is Adam Remjan. I'm the managing director of Orion Additive Manufacturing. And what we do is we basically develop 3D printing processes for high performance polymers. So you can see behind me, we have a couple of 3D printers here, and these are some of our own 3D printers that we've developed. And basically the core value proposition of what we do is we use thermal radiation to help fuse the layers together in an FDM process.
Okay, cool. So maybe can you tell us also something about the product that you wanted to develop within the AMable framework?
Right. So basically, we set out to work with one of our partners, which is Monitorfish, and what their challenge was that they were wanting to produce an underwater camera housing, and they were doing this through traditional manufacturing methods such as CNC milling and using a lathe and turning. And this was a very complicated process. It involved a lot of material waste and a lot of production time to kind of get the parts back to them. So they wanted to take advantage of 3D printing and see if they could use the advantages of 3D printing with having freeform designs and having fast manufacturing and see if they can apply that to their underwater camera housing. The only issue is that with typical 3D printing processes, it usually creates porous structures that doesn't allow you to use the part underwater because water would leak through. This was the main challenge in doing this NIMAS project because we design our printers to work with high performance polymers such as PEEK and Ultim and PPSU. However, we haven't tried this with materials like ABS or other common materials that are quite widely used. So we weren't sure what was going to happen, and this was a really great opportunity to do this project through AMable to be able to kind of reduce the amount of risk for the customer and for the end user, and also prove that our technology can work with a wide range of materials, not just for high performance polymers. So the main challenge was basically to create this underwater camera housing, which you see here, and to make sure that right after coming off of the printer, it's hermetically sealed. So there are a couple of openings here. So this is what we would call the front, and all of the electronic camera components would go on the inside. And then we would seal this off with a seal and an acrylic cover. And then on the back here, on the top, is actually where we would fit a cable gland, and this also gets sealed, and the cable comes out. So this was the product and the result that came out of the NIMAS project through the AMable consortium, and we're really happy to report that it worked out really well.
You said that AMable was a great support, which is obviously good, but maybe we can go into a little bit of the details, which services you have been using in this project, and maybe also why, if you can tell us a little bit.
Great. So one of the other benefits of doing this project with AMable is that we do have access to these services and a whole network of experts from a bunch of different research institutes. So you yourself from Inspire, whom we worked with, we had mentors come into our project and give us advice, who have a lot of polymer experience, a lot of 3D printing experience, with a wide range of different materials as well. So we were able to tap into those resources and bring this expertise into our project. So what we did for this NIMAS project is that we utilized two services. One of them was design for AM, and the other one was data acquisition, which was really used in a way that we were focusing on what the strength properties and what the porosity was of our finished parts. The design for AM was done by MTC out of the UK, and the data acquisition was done through Brightland Material Center, which is a division of TNO out of the Netherlands. And the data acquisition was primarily used for looking at how our thermal radiation process in our printers increases the interlayer bonding and makes hermetic structures. Yeah. And they have a lot of experience in testing different polymers. So what we found out of that experiment was that we're actually exceeding the benchmarks for what other people are able to achieve and industry leaders are able to achieve in terms of tensile strength and Z direction. So when we look at the test bars that we're printing, We can print test bars flat, or we can print them vertically. And the flat ones were receiving a tensile strength of 36 megapascals, and the vertical ones were 31 megapascals. So this is actually just slightly exceeding what Stratasys is able to achieve with their test bars, because they claim a tensile strength of about 30 MPa. So we're just above, and this is with a very standard off-the-shelf basic ABS. So it's not an extremely high grade of ABS or anything like that.
Yep.
But just the fact that we're able to achieve that was really an important milestone for us.
I see that your product is obviously on the market already, which is quite an impressive achievement, I would say. So congratulations again also for that. And maybe another question that is going more towards the future. So obviously you are an additive manufacturing company already, or you represent an additive manufacturing company already. Therefore, I imagine that you are going to use additive manufacturing also in the future. Maybe can you give us some insights in what some future product will look like?
Yes, absolutely. So yeah, you're right. So we do manufacture these printers, and we also offer a printing service to be able to help people adopt this technology and understand what the benefits of 3D printing are. So this product is finished and it's already on the market, but the idea is that we can make other products custom made, tailored to every customer's needs, whether it's something that goes deep into the sea, into water, and needs to be hermetically sealed, or products that go all the way up into space. In terms of deep sea applications or underwater applications, we can also design other customized products that can be pressurized underwater. And we're actually involved in another AMable experiment called the AMCube project. So this project is now our next project and continuation of the AMable project. And this project is focused on going out into space, actually. So we're now working with a customer called German Orbital Systems, and they've been so kind to work with us on creating this CubeSat frame design. So this is basically a CubeSat frame that's created from PEEK. We can create these CubeSat frames faster, but not only faster, but a lot lighter. PEEK having half the density of aluminum means that we can actually reduce the weight by maybe 50% and integrate a lot more into the CubeSat frame structure. Mm-hmm. And just by reducing the weight by half on a small CubeSat, 1U CubeSat like this one, we could probably reduce maybe up to 25,000 euros on the launch costs of just one satellite.
Pretty cool. So you could say that AMable brought you from the deep of the seas to actually space. So it's pretty cool achievement also for us. So maybe one last question to conclude. I just want to know a little bit your experience. So really your experience with the AMable project partners. So not too much on the technical side, but more on the personal relationship side. Let's say, how was it?
Yeah, no, it was really great because, it's like I was saying earlier, there's a lot of experience that we're able to bring into these projects, not just the experience that we have ourselves, because we're focused a lot on developing these machines and these processes, but we're familiar with our own processes, but we're not familiar with other processes. So being able to pool in all of the knowledge and also all of the resources really help with bringing this project forward. And being able to understand also some of the intricacies about working with polymers or working with 3D printing processes. Not only that, but we're also able to take advantage of some of the equipment and other resources that the consortium brings. So having access to some of this testing equipment would be otherwise extremely expensive to use. And I think the last part of it also is just being able to spread this knowledge around and be able to kind of have this community that we can share our knowledge with, right?
Okay, great to hear that AMable enabled you to go on with the development of your company and allowed you to develop new products. So yes, I would like to thank you again for your time, and good luck for your next projects, and all the best for your company.
Thank you very much, Francesco.